In this series of videos, we're going to show how to perform a hypothesis test for a population proportion. Now, remember that if we're interested in P, the true proportion of members of a population who share some characteristic, our best point estimate of P is given by P hat, which is the number of individuals in the sample with the characteristic divided by the sample size n. Now, as P hat is a statistic, it has a sampling distribution. And under certain conditions, its sampling distribution is approximately normal with mean P and a standard deviation of the square root of P times 1 minus P divided by n. Now, this is going to hold as long as certain conditions are met. First of all, our sample is a simple random sample from the population of interest. Second, we need n times p times 1 minus p to be greater than or equal to 10, and we need the sampled values to be independent of each other. Now, it's this mathematical theory, the fact that the sampling distribution of P hat is approximately normal, that our test is based on. Now, step 1 of our test is to set up the hypotheses. The null hypothesis is always going to be HO, P equals P sub 0, where P sub 0 is the assumed value of the population proportion. Our alternative hypotheses are either going to be that P is not equal to P sub 0, in which case we have a two-tailed test, P is less than P sub 0, and that would be a left-tailed test, or P is greater than P sub 0, and that would be a right-tailed test. So now, before we can proceed with the test, we have 3 assumptions that we have to check off. First, our sample has to be obtained by simple random sampling. For problems in our textbook or online, this is simply stated in the problem. Next, we need to check that n times p sub 0 times 1 minus p sub 0 is greater than or equal to 10. Now, you might notice that this looks like the requirement we gave a few moments ago for assuming that P hat was approximately normally distributed. But note here, though, that we're calculating this expression using P sub 0. That is the hypothesized value of P up in the null hypothesis. And this is calculated this way because, remember, in a hypothesis test, we're interested in the probability of our sample results, assuming that the null hypothesis is true. So we're going to use the value P sub 0 from the null hypothesis here when we check this assumption. And then finally, we need our sampled values to be independent of each other. We can check this by requiring that our sample size n is no more than 5% of the size of the population we're sampling from. As before, in step 2, we select the level of significance. Now, in step 3, we calculate the test statistic. So we're going to calculate P hat minus P sub 0, and remember, P sub 0 is the hypothesized value of P from up in the null hypothesis, divided by the square root of P sub 0 times 1 minus P sub 0 over n. And again, note that we're using the hypothesized value P sub 0 in computing the standard error. Now, this test statistic will have an approximately standard normal distribution, and that's why we label it as Z sub 0. So, in step 4, we let the software calculate the p-value. And we're going to write down the p-value and sketch the p-value region on the probability distribution. If we have a two-tailed test, the p-value is going to be represented by the area under the curve out on the tails of the distribution. The p-value for a left-tailed test is the area under the curve out on the left tail of the z distribution to the left of the test statistic z sub 0. And the p-value for a right-tailed test is going to be the area under the curve to the right. In step 5, we're going to compare the p-value to alpha. If the p-value is less than alpha, we reject the null hypothesis and conclude the alternative. If the p-value is greater than or equal to alpha, we fail to reject the null hypothesis. And finally, in step 6, we state the conclusion in terms of the original research problem. We want to be sure to state whether or not there is sufficient evidence to conclude that the alternative hypothesis is true. Now, in our next video, we'll pull up an example and we'll run the hypothesis test.